The newly born universe buzzed and frothed with boundless energy. Even after the raging furnace of the first few minutes had died away, temperatures universe-wide were more than 100 million degrees. For thousands of years, this primal heat burned a cosmos of plasma, a super-hot mix of particles and radiation. Until, one day, it changed forever. That day arrived when the universe was almost 400,000 years old and had cooled to about 3,000 Kelvin. In this now comparatively tepid soup, lone electrons met lone protons and finally could stick together, forming the first atoms. But this was not all, for as each electron and proton bound together, a small amount of energy was released. A packet of energy that raced away at the cosmic speed limit, the speed of light. A particle of energy born in the formation of a hydrogen atom. A particle we call a photon. A particle of light itself. This photon was far from the first, but as the universe began transitioning from plasma into neutral gas, light could then, for the first time, stream freely through its reaches. And so, our photon's long journey began. It headed out first into the universe's dark ages, a time before the first stars burned, a time before the first galaxies formed. In the eerie darkness, gravity pulled on mass to mold the first seeds of cosmic structure. But the photon sped on and noticed nothing. Eventually, the first stars burst into life around it. Massive and bloated, these ancient suns burned themselves out in a cosmic blink of an eye as the first supergiant black holes grew rapidly between them as they eagerly devoured mass. But the photon sped on and noticed nothing. The first galaxies began to assemble. The sky lit up with the fires of uncountable young stars across the cosmos as they began to fuse the initial hydrogen and helium atoms into heavier elements. But the photon sped on and noticed nothing. Millions steadily turned into billions of years, and as galaxies grew and matured, eventually the intense light of young stars began to settle. The photon's journey could have potentially lasted forever into eternity, but after almost 14 billion light-years of travel, a large spiral galaxy steadily came into view. Its destiny was set. Near a small blue dot orbiting a small white star, after crossing the last few thousand light-years, the photon collided with a piece of metal, part of a telescope built by humans and orbiting near the planet Earth. The photon's energy was completely absorbed, energizing electrons and registering on detectors. But as the photon vanished from existence, its billions-year-long journey complete, it still simply did not notice. Because, to the photon itself, the journey never took place. 13.8 billion years of cosmic time disappeared in an instant. Yet how can this be? Light has existed in the universe from its earliest moments and will continue to exist long after humanity and the stars are shred to dust. But just how does it work, and how can it seemingly last forever? And perhaps most importantly, what even is it?